Kamiak Butte is a range of quartzite substrate rising above the Palouse-Luce Plains. It is an ecological marvel and is absolutely teeming with life. Today, we are going to take a closer look into the various factors contributing to the unique landscape and community that is Kamiak Butte. Sitting on the eastern border of Washington state, Kamiak Butte was actually on the very edge of the North American plate, immediately following its split from Pangaea. During the Paleozoic era, and as the North American plate drifted towards where it stands today, present-day eastern Washington was locked under seawater, where millions of years' worth of sandstone and other marine sediments were deposited. At around the same time, the Laurentia piece, a small broken-off piece of Pangaea, began slowly subducting under the North American plate, causing the once underwater edge of the plate to soar above sea level, creating dramatic, enormous, extremely active volcanic ranges. As the mountains rose and experienced varying degrees of pressure and temperature changes, the once softer and lighter colored sandstone became the redder, more solid quartzite. Here we can see the reddish color coming out on a large exposed intrusion of quartzite on Kamiak Butte. Immediately after the quartzite was deposited into the basins adjacent to the Rocky Mountains, the subduction of the Farallon Plate underneath the North American plate caused water to be carried into the mantle, which was pushed up towards the surface as well as east over time, pushing on and lifting and uplifting the surface of the continental crust. It is this process that created the large intrusions of igneous rock known as batholiths along what was then considered the coastal region of the plate. The Columbia River flood basalts are considered the youngest flood basalts on the planet today. Following the construction of Kamiak Butte and the other granite intrusions, the North American plate began to slide over the Yellowstone hotspot, known for its current location directly underneath Yellowstone National Park. This hotspot, along with other geologic tensions being imposed on the western edge of the plate, resulted in an uplifting of rock from deep in the mantle. The floods occurred at varying intervals, overlaying the surface with fresh basalt every few million years, creating a thick layer of purely basaltic bedrock, which now lies underneath much of eastern and southern Washington. These flood basalts tragically covered up a majority of the regional intrusions, including Kamiak Butte, which is why today only a small portion of the intrusion remains visible and above ground. What remained was the very top of Kamiak Butte, surrounded by essentially nothing but fresh basaltic layers. In present-day Idaho and Montana, there existed an enormous lake, which had been blockaded by a leftover piece of ice from the most recent glaciation. Eventually, however, this ice block failed and gave way to a truly incredible amount of water, which tore through the otherwise peaceful basaltic Washington geography. This process repeated several times, although not each flood had the same significance as the original one. These repetitive and violent floods created incredible geologic features, including the scablands of eastern Washington. As the ice sheets began pushing forward, they gathered up huge amounts of debris and sediment, which would be deposited at the edge of the ice sheets in moraines. This sediment is commonly known as till and can help us understand the history of ice sheets throughout the ages. During the last ice age, the ice sheets of the central North American plate left behind an impressive amount of fine-grained, nutritious silt that was lying out on the Wisconsin surface. Great winds carried the silt over a long period of time all the way from Wisconsin to the Palouse region, where it settled into dunes like those found in a desert. Palouse exists within what is known as a marine modified continental macroclimate. This specific macroclimate type is a reference to the both marine and continental air masses flowing into the region as a result of its specific location near the Pacific Ocean, while still being inland and surrounded by dry land. The Palouse Hills experience distinct seasonal changes, relatively short growing periods, and more moisture than most other macroclimates. In eastern Washington, summers are hot and dry, while winters are long and snowy. The hot summers are a result of the rain shadow created by the Cascades, which largely prevents rain from spilling into the region. The movement of moist air east from the ocean is blocked by the Cascade Range, while the Rocky Mountains shield the region from the cold winter air masses from Canada. Some air from both directionalities does seep past the surrounding barrier mountain ranges and into the inland basin, which is why eastern Washington has both continental and marine climate patterns. This region receives approximately 21.51 inches of precipitation per year. When looking at monthly averages through the years, November has the highest average precipitation at 2.83 inches, with December and January as close seconds. This is then followed by a 6 to 7 month decline in the precipitation levels until July, which receives the least precipitation with an average of 0.57 inches. As mentioned before, Kamiak Butte is located within the continent, resulting in distinct seasonal changes, but relatively temperate temperatures. Within the specific range of the butte that we are studying, winter is defined from November to February, with temperatures ranging between 20 and 30 degrees. Spring occurs from March to June, when temperatures are averaging 30 to 45 degrees. The summer months last from mid-June to mid-September, during which time temperatures range from 40 to 85 degrees. On average, temperatures do not get below 20 degrees Fahrenheit and do not exceed 90 degrees during the hottest times of the year. Precipitation in 2021 was significantly less than during the rainy season than it normally is. During the growing season, when temperatures reached above 40 degrees for more than 2 days at a time, it is critical that plants receive the necessary amount of water to have successful growth. However, as we can see, the months of May and June both received less than 0.5 inches of rain, despite the average precipitation for these months being above 1.50 inches for May and over 1.0 inches for June. Fortunately, during the growing season of 2022, just as the land warmed above 40 degrees, Kamiak Butte received significantly more rain than on average. While the total precipitation for 2022 was not significantly higher than the yearly average, according to the PRISM data on Table 1, that year can be considered a flush because of the abnormally high rates of precipitation during the most critical growing time of the year, which can be observed in the data for June. The north-facing aspect consists of 204.7 acres of highly vegetated green woodland and is home to a fantastic array of flora and fauna. The most significant factor impacting the north face is the reduced solar radiation due to the incline and aspect of the face. As a result, the temperature is slightly lower on the north face, and the moisture levels are significantly higher. Soils with heavy canopy cover tend to have a higher pH than surrounding grasslands, resulting in a better cation exchange and a more successful and diverse plant community. It is much more competitive on the north face than on the south, which is why the trees are taller. They have a bigger incentive to grow. Most of the old growth represented in the data here is Douglas firs. Besides the trees, the north face is covered in a grand array of short bushes, shrubs, and ferns. Some of the most prevalent species are the ocean spray and mallow ninebark, which are better suited for more moist conditions. The south-facing aspect of Kamiak Butte comprises a total of 175.8 acres of shrubland and consists of mostly open grasslands littered with the occasional ponderosa pine. The pH of the soil is lower than that of the north face due to the decreased canopy cover, and water and other nutrients are harder to come by. On the south face of Kamiak Butte, the same tree species are present, but in much smaller numbers, and in slightly different distribution. The ponderosa pine, which is successful in drier regions, is more prevalent on the south face than on the north face, and serves as the habitat for many species. The QMD of all the trees is just slightly less than that of the north face, measuring 18.15 inches. This makes sense because the trees on the south face are mostly ponderosa pine, which, as seen in this table, tend to remain under 80 feet in height and generally less wide than the Douglas fir, with an average DBH of about 17.04 inches. Sagebush and saltbush creosote bush are common because of their adaptability in arid conditions. The willow flycatcher is a species of tyrant flycatchers that occupies the northwestern region of the North American continent, south of the Canadian border. Originally, there was no distinction made between these little birds and their close relative, the alder flycatcher, until 1975, when it was noticed that the two birds have different songs. The willow flycatcher is a beautifully specialized product of evolution. Rather than evolve to better handle the cold weather of the Pacific Northwest and risk food insecurity in the winter, this small bird braves the open air and follows the sun year-round, journeying across North and South America twice per year. The male flycatcher defends their territory and locates food through a behavior known as sit and wait, typically from the comfort of the mallow ninebark. Thank you so much for listening to my presentation. Have a great day.